All right. We're going to talk about applications. And the first thing that we're going to talk about, and the first thing I want to stress is that these are specific ways to do these different applications. There are different ways to do these applications, many of which will be, maybe guess and check, maybe some of the ways you can see it. Again, these are just going to be for sure guaranteed ways that will work. I'm going to gauge timing of tests based off of these. So if guessing and checking is the way that you're doing it, that's fine. But if you're going to be taking 20 minutes to do it, that's something to deal with. So Chris drove up to see her sister U of I. Average 40 miles. Driving there on Friday. She returns home on Saturday. Less traffic, 48 miles per hour. A couple big things here. Okay. First of all, you need to remember that distance equals rate times time. Now, the other thing with linear applications is that you always have to try to figure out what are two items that are worth the same thing, because that's going to create the equation, the equality between the two. And so, in this problem, what's the two things that are the same? Your distance down is going to equal the distance back. And yes, I know you might be saying, well, just look at the stupid odometer, and Krista can figure it out that way. This is one of those things where sometimes the applications don't quite fit real life, and so it's more or less an intellectual exercise. So those are the two things we know to be true. We don't know how far the distance is, but we do know that the distance she drove down is equal to the distance on the way back. So, sorry for the pause. Okay, so the distance down is equal to the distance back. So, going down, and so again, distance is equal to rate times time. So we know going down, Krista was driving 40 miles per hour on average. We don't know how long she took, but again, we put in a variable when we don't know things. And the distance back is a little bit different. I mean, we know it's the same physical distance, but in terms of coming up with a formula for it, it was 48 miles per hour times, and it took an hour less, so you're going to get 48 times x minus 1. And then from there, you just solve things out. So x equals 6 hours. Now, the one thing you do have to be careful of is what's your answer? What are you asked to? What's the question that you're answering? And in this case, if you look back up here, the answer is not 6 hours because they are asking you what is the distance between Chris's house and U of I. ACTs will oftentimes do this, so will multiple choice tests, finals, things like that. Or they would ask you what's the round trip distance. Things so that the answer that you come up with is not your final answer. The numerical answer you come up with down here isn't your final answer. So in this case, you'd have to go 40 times 6 to come up with your final answer of 240 miles. In example 2, slightly different, and again, this is one which probably lends itself a little bit more to guessing and checking, but solution problems. Mixing up all sorts of things, in this case, antifreeze. In terms of thinking this out, you've got this vat that you're mixing all this antifreeze in. In the first part, you've got 10% solution. And to that, we're going to add in 25% solution. And at the end, we want 15% solution. So what you have to ask yourself here then is what are we comparing? Okay, so we're having, we're taking 10% solution. We're adding 25% solution to it. And we're going to get 15% solution on the back end. So we know I have 5 liters of 10% solution. And I'm adding in, we don't know how much, so I'm going to have that be x. So 5% of 10%, 5 liters of 10% plus x liters of 25% solution. Now the question is, how much 15% solution is there? Now notice, these two things here Okay, this. Okay, so this here, oops, sorry. Okay, so this here and this here, when we add it together, it's going to be one big volume of, one big vat of stuff. So again, that's going to end up equaling a total of X plus 5 liters. So if I add up 10 liters into it, I've got 15 liters total. If I got to add 2 liters into it, I have 7 liters total. And so if you look at the equation, it makes sense, and you're saying, oh, well, duh, Mr. Hayes. 5 plus X is going to equal 5 plus X, which is true. The question is, how can we get something else so that we can have something that will compare the two? And the thing that's going to be there is going to be whatever your solution is, in this case, antifreeze. In this vat down here, how much antifreeze do I have? How much is antifreeze? Okay. So in this case, 10% of the 5 liters is antifreeze. So that's going to be 0.5 liters. In a 25% solution, it's going to be 25% of whatever amount that you put in for X. And that's going to be the key here. So for 5%, I'm going to multiply that by the 10% solution. That's going to be 0.5 liters. In the X liters, I've got 25%. And then in the 15% solution, well, yes, you could say, well, it's 5 times 0.10, and you've got 25% of X. We also know that in the final result, it's going to be 15% of X plus 5. And so this X plus 5 up here, I'm going to multiply by 15%. And so now you've got 2 equal quantities set up differently. Okay, I've got a part plus a part is equal to the whole thing. And that's how we're going through and treating it. So then you'd go through and you'd solve this out. So I've got 0.5 liters here. I've got 0.25 liters here. 0.25 X liters here, I'm sorry. And then this would turn out to be 0.15 X liters plus 0.75 liters. And then you go through and you solve it. So 0.02 liters. And now in this case, that happens to be what the solution that you're looking for, so that would be it. So you'd have 7 liters total. Now, some people would say, well, you could just kind of guess and check this, because if I added 5 liters to the 25% solution, the average would be 17.5%, and you could kind of work your way back. And, the answer is, yeah, you're right. But again, that may or may not, depending upon how you set up stuff, that may or may not give you the right answer quickly. So, let's say thought. Last question, last example. Let's say I earn $1,456 in interest from 2 different investments. I invest $28,000 in one mutual fund that lead at 4.8%. The S is 4.5%. How much should I invest in each? Real quickly, remember, interest is equal to your principal. In other words, how much you're investing times rate times time. Now in this case, time is 1 year. So I've got investment 1, interest, plus investment 2 interest, and that's going to equal my total interest. So that's going to be $1,456. So the first one I'm earning 4.8% on. Now how much am I investing there? I don't know. It's going to be X. The second one I'm earning 5.5% interest on. And how much is that? The rest of it's going to be the balance. So for example, if the first investment is $10,000, the second one would be $18,000. If the first one is $5,000, the second one is going to be $23,000. And you get that by subtracting. So I'm going to take, since I'm investing X, I'm going to subtract X from $28,000. And then you're going to multiply through and solve that out. And so when you do all of the math here, you end up getting an answer of X equals $12,000. So your 2 answers are going to be 4.8% interest. I invested $12,000. 5.5% interest, I got $16,000. That's that. So we'll have some time to work on these in class, but the biggest thing to do with these things is just work the problems and get used to doing them. Okay? So thanks so much. I will see you guys later this week.